Good afternoon, everybody, and welcome to our webinar entitled Traffic Data Collection and Analysis. It's great to see so many people joining us today, and we really appreciate you taking time out of your busy schedules to attend. My name is Harrison. I'm a Business Development Manager here at Ramudden Digital, and I'm joined by Ajay Kaushik. He's our Senior Director of Technology. Over the years, Ajay and myself, we've worked with numerous diverse traffic data collection technologies, and I wanted to share what we've both learned in the industry in terms of best practices, some of the gaps we've seen, and what the future holds for traffic data collection and analysis. You may have noticed that recently we've been rebranded from Stinson ITS to Ramudden Digital. Our services, products, and commitment to our customers has not changed. We've simply been rebranded to better align with companies operating within the Ramudden Group. Before I start, I just want to give a big thank you to Ajay for working incredibly hard on this presentation and sharing his unique insights and perspective on this market. All the images and graphics you see are all of Ajay's hard work and his attention to detail. And also on the right-hand side of your panel, you do have a questions tab. So any questions would come to mind during the presentation, please post them there. And at the end, we'll address all questions, and it would be great to have a list of them waiting for us when we get into that section. And one final reminder, as always, we have our quiz. First person to answer correctly will receive a prize, and this will happen at the end of the broadcast. So let's get into the agenda for today. Okay, so we're going to touch on, we're going to start with traffic data inventories. And basically here, we're going to look at three tax specified data collection inventories and explain the relationship between roadway conditions, traffic data collection, and control conditions. And then we're going to get into the technology side. So the benefits and drawbacks of certain technologies operating within our market. And I'm sure you're going to be familiar with most of these, if not all of them. So just an educational refresher. And then we're going to touch on data collection needs, and this is going to be more focused on your municipality's specific environment, the infrastructure related to your municipality, and the needs that will inevitably change based on these geometrical conditions. And then finally, we're going to look at network and data collection issues. So we're going to share our insights on what municipalities are facing in terms of challenges. And then finally, our vision for the future, how we look to address some of these challenges with a common, agnostic, and integrated approach to traffic data collection and analysis. So traffic data inventories. This isn't anything new. I'm sure you guys are all familiar with traffic data inventories and the relationship between them. So they fall into three categories. The first being roadway conditions, traffic conditions, and traffic control conditions. And it's basically related to the planning, collection, and implementation of the data collected. So before collecting data, it's important to understand the existing conditions of your roadway, as this will not only influence driver behavior, but potentially limit the usage of data collection technologies. So as an example to kind of bring this concept home, let's say your municipality is planning to install a permanent non-intrusive count station. This could be radar or video-based. Understanding the existing conditions will help you determine some key points of the infrastructure that's required. So whether an existing pole is available to mount the non-intrusive sensing hardware on is important. And if a pole isn't available, is there enough space between the curb and the property line to mount the pole? Are there underground utilities that should be accounted for? How is the grade separation? And will this affect the height of the pole? So before even deciding whether to use the traffic data collection device, you need to understand what the existing conditions look like at your site. So once these conditions have been assessed and appropriate data collection technology is deployed, insights can be derived, and these can be in the form of TMCs or operating speeds or ADTs, etc. So using that data, now we can make actions on the data. We can implement control measures to modify driver behavior, and this could be as simple as some new signage or a flashing beacon, or something more complicated like an automated speed enforcement system. The key is understanding the relationships between these 3 points and then acting on the data collected to influence driver behavior. For the purposes of today's webinar, however, we're going to keep our focus on traffic conditions. Ajay, is there anything you'd like to add here?
I think it's worth mentioning that Transportation Association of Canada, TAC, not only recommends what type of data should be captured for each one of these categories that you've just mentioned, but TAC also provides guidelines and methodologies about what level of data makes sense for what type of organization, whether it's a small municipality or a big city, what type of data makes sense for them, how to establish an inventory, what software should be used for managing the data. And traditionally, these softwares such as pavement management system, bridge management system, or maintenance management system have been used. And we'll cover a little bit of traffic data management software later in the webinar today. But that's pretty much what I would like to add. This was pretty good. Thank you.
Excellent. Thank you. Okay, so let's take a deep dive into the various forms of traffic condition data and popular data collection technologies. So before we start talking about the specifics in traffic data collection technologies, I want to recap exactly what we're going to cover in this section. So our focus is here will be on the conditions data and the three major categories of data that can be captured regarding these conditions. The first is the volume, classification, and speed, and there are three major categories of data that we can capture regarding, and the data can be captured in different intervals, or the data can be captured in a 1 day, 3 day, or a 5 day count, or in real time as a permanent count station. This data could be segregated based on the type of infrastructure, such as an intersection or a mid-block or an active transportation facility, as all these types of infrastructures could have different data sets. And of course, the ultimate objective is to produce standard metrics for the road infrastructure, such as annual average daily travelers, summer average daily travelers, winter annual daily travelers, etc. But this gets more interesting when we start looking at the volume data and using that to calculate the level of service, specifically at signalized intersections. We could spend a lot of time discussing ATS-PM data, but in the interest of time, I'd like to save that discussion for another day. But there is one thing I'd like to touch on that I think goes a bit missed in the traffic data collection industry, and that's on collision data. And I think we think this is a very important aspect of traffic condition data, and there's some gaps in how it's currently collected. Traditionally, collision data has been collected from police reports, insurance reports, but collisions are rare and not all collisions are reported accurately. Due to this, it's very difficult to implement appropriate control or safety measures because collision data is lacking. This has led to new methods of collecting and collision data in a different format. Basically, it's the potential for a collision, or like we like to call it near miss or conflict. So near miss events occur significantly more frequently than collisions. And by measuring their occurrence of these events, we can gain insight into future incidences and their severity. But more importantly, using the data, we can implement measurable safety improvements before a collision even occurs. So to conduct a near-miss study, typically we would record video for the area of interest and then use AI processing tools to analyze vehicle speeds, trajectories, braking, estimated time to collision, and a whole host of other important factors. This gives us an accurate representation of how critical a collision could be, the most frequent type of collision that would occur, and where they're most likely to occur. So we can target safety improvements before anyone is injured. But for this webinar in particular, we're going to focus on two segments of traffic condition data: the traffic volume classification and speeds, and the collision data. So I'm going to try and go through this as quickly as I can, because I know a lot of you guys are familiar with traffic counting technologies already. But at the far left, you're going to see more traditional methods of collecting traffic data, including the manual counter, typically used by summer students, the pneumatic tubes, and the inductive loops. The pneumatic tubes, great tool for collecting vehicle classifications. You can measure the number of axles using the tubes. Drawbacks are you have to lay them out, you endanger your workforce by laying them out through multiple lanes of a road, and they get damaged in the winter. Snowplows can tear these up, so they're not usable all year round. We get particularly bad winters in Canada, as we all are aware. Inductive loops, These make, they're typically, we think of inductive loops, I think of intersection control, but these are also can be used as a count station, milled into the pavement in pairs to collect vehicle speed, volume, and class. Again, very similar to tubes. There can be some damage to the roadway when you do cut a loop into the ground, but in terms of accuracy, it is very accurate. Radar devices, and now we're getting into the more technological solutions. And as you know, we supply a whole host of different radar devices for traffic counting. And the benefits of the radar, of course, is it's not intrusive, collects very accurate speed data, collects very accurate volume data. And depending on the type of radar you're using, the classifications may be limited to a select certain amount of bins or more advanced. It really depends on the radar you're using, Doppler or FMCW, you know, in those cases. LiDAR, a very new technology, and maybe not as new as we think, but it's basically an infrared sensor that profiles a vehicle and gives you a more in-depth analysis of what that vehicle's shape looks like. Ajay can probably speak more to LiDAR. And finally, video analytics. Video analytics is, again, something we're very comfortable with. We've worked with many vendors to produce not only video TMC data, but also conflict data in post-processing scenarios and real-time scenarios. And, you know, there are some drawbacks to video as well, including weather, fog, dust on the lens, or the lens getting dirty. Ajay, is there anything I've missed here? Would you be able to add any information to this section?
Well, I have a few comments. I think I feel that municipalities and cities are adopting modern technologies at a very good pace. If you remember 2 years ago when I was here, it was an effort to convince municipalities and cities to use radars. There were probably less than 10% municipalities using radars. Nowadays, you'll probably find 80% of municipalities using radars or video analytics. And I also feel it's important to mention the hurdles that traffic technologies face when they decide on some of these technologies. And I think 3 of these hurdles that we can mention is, first one is accuracy. There are a ton of new sensors out there in the market, and some of these manufacturers make big claims about the accuracy of their sensors, which are not necessarily true in the most practical road conditions. And we work with traffic technologists who really spend a lot of time trying to test new products. So that's something that every traffic technologist have to be very careful about. The second one is understanding the limitations of the technology itself. You mentioned that pneumatic road tubes cannot really be used in snow or winter conditions. It's the same with radars, for example. They are limited in their use in tunnels and closed spaces, unless some of these special radars, which can be configured for such for reducing the reflections that they get. But radars and lidars are great in the sense that they can work in snow and fog. Similarly, we have seen how resolution of cameras have a major impact on the accuracy of videos or video processing. The lower the resolution of the camera, the lower is the accuracy of what you're trying to achieve with it. And of course, cameras need to be cleaned for optimal performance, especially after the winters. And I think the last thing which is worth mentioning is the long-term cost of adoption of any of these new technologies. If it's not cost effective, it's not going to last. The cost could include not just the cost of the equipment, but also the cost of, let's say, configuring the equipment and making it, integrate with other systems that are on the traffic signal controller or some other places, and also the cost of training the city's resources. Let me ask you a question, Harrison. You have mentioned all these technologies. How would you decide if a temporary count is sufficient or a permanent count station is needed for a particular study?
That's a great question, and all the technologies are relevant, I believe, and it's important to understand the context and the purpose of the study location. I think so. Traffic data collection needs can be classified based on the road infrastructure. So for rural municipalities, for instance, it makes sense to do a 1 day, 3 day, or a 5 day count. Some municipalities with the tourist-friendly locations may consider a data collection on the weekends or seasonal data collection. And of course, if any of us get persistent speed complaints, it's important to use that complaint using a traffic count. For smaller town centers, Traffic operations can be added to this list because they manage potentially a handful of intersections and maybe would like to get turning movement count data from the major, from those intersections. And perhaps to plan for, traffic events, special weather, or community events. For highways, traffic operations have a higher significance, specifically near the cities. Incident detection and management is also a high priority. So therefore, permanent counts make sense on larger highways, and temporary counts make sense in areas where they have seen an increase in complaints or incidences. For larger cities, there's a lot more purpose for traffic data collection. I'm not going to read all the purposes, but I think it's becoming more and more important to get a better understanding of what is happening during the weekends, weekdays, peak times, and how these are differentiated. What's the difference between a Friday peak time, between a Sunday peak time? The traffic conditions change during the winter and the summer. And what happens when it snows or after a city's implemented a new adaptive traffic control technology? We want to be able to measure the benefits before and after the implementation of a new technology. So overall, the traffic data collection needs define what technology to use and for how long the traffic data collection should happen for. And a lot of times it is a before and after study. So what do you think, Ajay? Am I missing anything here?
Oh, no, I think this is pretty good. I would like to kind of add a little bit more context to this. Let me show you what problems that I see from here. And it's especially relevant when we talk about network data collection and analysis. So assume that these are, right, and I'm going to take this with a simple example to understand the problem. Assume that these are two intersections on a road, which is used by pedestrians, bikes, and vehicles from different classes. And let's assume one group from the city's traffic department is utilizing a radar to collect the data from a mid-block. The radar may transmit the data to a nice, secure cloud platform in line with the city's IT department's, security and privacy needs. The data may be updated every 5 minutes, and maybe the platform gives you a really nice dashboard and data dashboard so that the department can actually compare this data with other mid-block counts and other things, But let's say there could be another system here. Let's say the first intersection has another system which could be installed for car and pet detection for the traffic signal controller with another cloud here. Let's assume that the data is delayed here by 2 hours. Okay. Now, this is just two systems. The city may have a bunch of other sensors, and they all can have their own data system. For example, here we have a radar feedback sign. It could be another system on intersection, which could not just give you pedestrian detection and or car detection for the traffic signal controller or TMC counts, but can also probably give you conflict data, say something similar to AMAC that we supply here, or maybe a completely different software which system which gives you just print and bike data. And this example that you see here is a very good example of data silos. It's a reality for most municipalities where traffic groups, like let's say traffic signal groups, work with a different system, a different software, and traffic safety groups work with a different system, and traffic data collection group is working with a completely different system. And as a traffic technologist, understanding all of these different types of sensors, getting the data to a common platform, maybe, and to be able to either change the traffic signal timing, which really needs real-time inputs for traffic volumes and traffic safety data, or utilizing it for long-term planning is something which is very, very difficult. And this is just one example. In real life, the problem is even bigger. So imagine having a city with many roads and many different types of smaller roads, larger roads, and many types of sensors. And some of this old data could be in actual printed sheets. And you could have a ton of different types of cloud softwares. And nowadays there's a trend where everybody wants to use Google data. People also want to use, say, travel time data. And there have been a lot of talks in webinars that I follow now, where people are talking about using data from connected vehicles. So when you have all of this, I think, looking at this and especially looking at the past data, present data, and you might even have predicted data. Of course, there are traffic teams working on this data problem, not just one person. There are teams of people who are working on this. But every year, this becomes bigger and bigger. New technologies come in, new products are released, and the problem just gets bigger.
It's a very, I mean, I'm sure many cities are experiencing the same problem, and I'm curious to hear what your solution to this would be, or a potential solution for the future.
Yeah, I don't think anybody has a proper solution yet, but let's say if you have to give a hypothetical solution for now, we need to understand the future, and we need to look at where the municipalities want to be in the next 5 years or 10 years, and our plan has to be aligned with that plan. And everybody has their own versions of future transport strategy, but I particularly love the movement and place framework suggested by Australian New South Wales Future Transport Strategy 2056. It's 2056 strategy. So it's sometimes funny, but it's a brilliant document. It's available on the web, and I recommend everybody to just download it and look at it once. It's brilliant. But when I look at this framework, it is trying to include more pedestrians and bikes in the future, and it divides the type of roadways into 5 of these categories that you see: motorways, movement corridors, larger streets, smaller streets, and just places for people. And the highways here on the top that you can see, they have fast movement for vehicles and less place for people. While as you move right, the movement becomes slower and slower and slower, and there's more and more place for people. And that's how they envision this. So assuming this is how most of the cities are trying to probably go, I love this concept. And I just want to modify it a little bit to present our version of the near future. And if I look at that, I just want to add the safe movement and place framework. Again, inspired by exactly their strategy, but just the way we look at it, let's say the highways, probably controlled by the highway authorities, can utilize volume, speed, and conflict data to decide how fast the movement should be to make the highway safer for vehicles. Automated incident detection and traffic management can also be part of the strategy. And they could be controlling speed limits, or they could be giving warnings to people that, hey, there's an accident further ahead on this particular lane. So this is what this highway people can do, but they have to look at both the data, volume and speed, and safety data. And similarly, the cities, on the other hand, could be looking at similar data for volume and speed, and also safety data for different parts within the city. And they could be, changing the control conditions on the roadways almost real time to make the roads safer based on what are they seeing on the roadway. And I feel it's very important to add that authorized data sharing between different provincial, municipal, and city traffic organizations could be very critical for the success of this, where not only traffic alerts, but also traffic data is shared between the cities to improve traffic congestion and safety. If the roads are connected, the data should also be connected. And I think we know some, I know Terry is here on the call, and Northwest Territories is doing a great job at getting something similar in there. But that's where most municipalities or cities want to go, and provinces have to literally take a lead to get this done. But we're just talking about this at a very abstract framework level. How do we design a practical solution for the future from this? So the idea is there, and I would suggest integration first approach to systems would be the key. All systems, whether they're related to road infrastructure, such as traffic signal controllers or traffic sensors or holiday calendars, construction schedules, even weather data, needs to be integrated for just the relevant data that can be used by cities. All of these cloud platforms may have a lot of data. You don't need everything in here. You only need the right data, the relevant data, the abstract level of data to be here. But there needs to be a device management in place. There needs to be some kind of an automation of algorithms for either local or supervisory control of traffic control devices in the field, and also store all of that abstract data about all the three conditions that you talked about earlier, traffic conditions, roadway conditions, or control conditions in a database, so that in future it can be used by different traffic departments or users in terms of pre-built data dashboards or customizable data analysis tools such as Power BI or Tableau. And there's also an element for manual control of traffic devices, which I guess cities will never let go of, and they need that really in place. So there'll be some manual control as well. And in trends, we can see there are certain companies in the traffic space which have started to work towards a digital twin for the roadways to provide better visualization of traffic data to cities. And I think that's the way to go. All of this data actually visualize how you look at the actual city and the roads would be amazing to look at and to analyze. Often our customers ask, how is it possible to integrate everything in one single system? And it's not so difficult. APIs and standard protocols such as NTC/IP are available to ensure that devices, sensors, and their cloud platforms are easily integrated into software platforms. But in future, there'll be a need for integrations with other traditional softwares. Like you remember the softwares that I talked about in your previous slide, like pavement management system, bridge management system, maintenance management system. All of this needs to come together to provide data sharing and provide the value of analysis, long-term, short-term, and almost real-time as well sometimes. So that's what I feel is for the future. For smaller municipalities, they'll say, hey, it's not possible for us to have a software like this. It's a standardization in traffic data reports, and analysis could go a long way in the future, especially when you would like to see, hey, how has the traffic changed in the last 5 years or in the last 10 years? Then the 5-year-old report and the 10-year-old report has to match. Otherwise, there's a lot of effort to get everything to work together. I know we are very close to the end of our presentation, but I would like to end this presentation by saying that I think traffic data technologists play a big role. It's a very tough job. They are a civil engineer, an electronics engineer, a software engineer, and a data analysis expert all at the same time. And they have all our respect for playing all of these different roles every day and for teaching us what we have learned from them and presented in this particular webinar. Arjun, do you want to close this webinar? Any comments from you?
Yeah, no, thank you, Ajay. That was very insightful. And I think you mentioned a lot of common concerns and topics that we can't, we're having trouble understanding. But when it's laid out like that and it clearly and kind of highlights the problem and the need for integrating different data sets, specifically including the safety data, which we find is very lacking at times, and then pulling it all back into something common. While it is a bit abstract, I think it's going to set off a lot of light bulbs and get us thinking in the right direction.
Yeah, I hope so.
Excellent. And as I mentioned earlier, the quiz, we're going to have our quiz now. So get ready. I'll read out the question, and then if you want to type the correct letter corresponding to the answer, just type that in the chat. So if you want to just move the next slide. Okay, so the question is, what are the 3 categories of traffic data inventories? We're going to show you the answers and just type the correct one in the chat, just the letter. And Samantha will read out our lucky winner.
We almost immediately had the correct answer, so someone was paying very close attention. Gold star to you. Alex, you answered C first, so you will be the winner of our prize. I will contact you afterwards to get your mailing address. And congratulations.
Congratulations, Alex. That's great. Well, I want to also mention, should anyone want to talk to us directly, and I'm sure everybody here has our contact information, and we can chat about traffic data collection. I can provide a one-on-one meeting with myself or with myself and Ajay. happy to assist you in any maybe challenges that you're experiencing, or you want some consultation on different types of devices to use, or have a unique problem, or want to conduct some sort of safety analysis. And those are all things that we're very comfortable with doing and assisting our clients with. And between myself and AJ, our expertise goes back fairly deep in this industry, and our relationships are very strong with the current municipalities and players. So again, I wanted to thank everybody for joining today. As always, it was great to have you on board, and I hope everybody learned maybe something little or something big. It doesn't matter as long as you learn something.
Yeah, and I would like to add that we're going to share the presentation in a PDF with all participants here, so you will have a copy of this.
Excellent. Okay, do we have any questions, Samantha?
I don't see any yet, other than asking about the presentation. But we do have, oh, now they're coming in. Okay. We do have about 15 minutes left allotted for this, so we are going to stick around and answer any questions you might have. So feel free to put your questions in the question window. The first one though, someone asked, do you know of any cities or other jurisdictions that have done a good job unifying / managing these different data streams?
Alex, I mentioned Northwest Territories is doing a great job of doing these, and I know Terry is here on this call. But also we see City of Toronto is doing quite a lot of work on that, and all the large cities have been working towards them. MTO has been working towards them, but they have different approaches to this. It's not just a unified software, it's a very distributed software. I think they are taking a very distributed and very nice approach to this. Everybody has a different approach, but all the major cities have some program or the other trying to do this. It's just not at a level where the silos have gone yet. It'll take a few years for all the silos to go and for all of that data to come together.
Excellent answer. Yeah, I think that covers it fairly comprehensively. Yeah, one thing I guess I could add is, it's sort of the privilege of the major cities is they can afford these kind of systems to house multiple sources of data from various vendors. For the smaller municipalities, it's harder though. They need something more cost effective, something more affordable to ensure all their data is not being siloed away. And on top, I want to add too to the bigger cities, when we do integrate devices into these larger traffic management softwares, not all the features sometimes are migrated to the new platform. Sometimes we lose some high resolution features from the data collection devices. A code that can't be modeled, or I know AJ probably would understand more about this than I do, but getting a device into someone else's platform, there can be challenges between agreeing between these two vendors and integrating the code from device into the.
Perfect. I think that's the only question that we have right now. If you have any other questions, you can email us and we'll be happy to answer that later. Samantha?
Yeah, I think we won't take up any more time from you guys. There's no more questions coming in, so we'll give you back a little bit of time in your day. And tomorrow you can expect to see a link to a video recording of the webinar and the slide deck in PDF form. And then if you have any questions, Harrison and Ajay's contact information will be in the follow-up email as well.
Thank you.
All right, everybody, have a great day. It was a pleasure.
Thank you. Bye.
So